Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We are now about to start yet another chapter on recursion. We've seen this twice before. First time we used it just to produce iteration. The second time we did a bit more complex recursion where we had branching. In this chapter we're going to continue talking about branching, and in some ways this is a refresher for the things that we're about to be doing. When we look at trees, we'll definitely need to use recursion for those. And it's also just good for you to see recursion again and again, because it's one of the things that challenges a lot of students. So for the first set of examples that I want to use for this chapter's worth of material, we're going to talk about graphs. A graph is a data structure that basically has pretty much no limits on it. It's made out of two things, one of which is a set of vertices. So we have a set of vertices often drawn as little dots, and so technically this is a valid yet boring graph. In addition to the vertices, we have edges that connect them. Now these edges can be directed, in which case we will have little arrows on our edges, or they could be undirected. Generally, a graph is going to have one form or the other. When they are directed, it's often called a digraph, short for a directed graph. So this would be a simple little directed graph. This vertex connects to here, and this vertex only connects down to this one. You can represent all types of different problems with these. In addition to having edges that go between the vertices, a lot of times we will be able to put labels on these. Often they will be numeric values. Sometimes they represent weights, sometimes they represent distances, sometimes they represent things like how much you can flow through there. All depends upon the problem that you're representing. But for example, I might have the following, we'll refer to them as weights, on these three edges that I have in this graph. Let's go ahead and let's put in one more vertex, and I'm going to do something perhaps a little interesting with this. Sure, and then let's connect that to there, and now I would need to put some weights on these. Depending upon what it is that you want to model, that one did not appear quite where I would like for it to go. That's interesting. Maybe if I just go through the middle, we're okay with that. The weights don't have to be unique or anything, so it's perfectly happy for this to also have a weight of 2. Okay. That does not move the 5, unfortunately. This will move the 1 up a little, I believe. There we go. Just want to get it off the top of the 5. So this is a somewhat more complicated graph. The vertices are often going to be numbered. So this is our first vertex. Is that even going to draw nicely? Nah, we're going to undo that. We'll just go ahead and put a 0 right up by this. And then this will be vertex 1. Vertex 2, and vertex 3. Now the reason for introducing this is that there are lots of fun, interesting, challenging problems that we can do using graphs. You know what, I kind of feel like I should make these stand out as being different from the weights. We'll make it so the vertex numbers are in red and then the weights are in black. Okay. Lots of the problems that we want to solve on graphs, not all of them, but many of them can be done using recursive algorithms. And so what I'm going to do in the following videos is we will see how we can code up this graph or any other graph inside of Scala. And then we'll talk about some of the algorithms that we could do on this and how we would write them recursively. So we'll come back in the next video and we'll talk about how to represent this graph.